everyone, my name is Timea Kovacs and I'm a PhD student at the MPIFR. I'm going to present our initial results on calculating the dispersion measure and rotation measure of FRB host galaxies using the IllustrisTNG50 simulations. The observed DM and RM of FRBs consists of multiple components, and the large sample of FRBs can provide a tracer for the cosmic baryon density and the intergalactic magnetic field. However, we have to carefully subtract the host contributions. So we calculate these using galaxies from the state-of-the-art cosmological hydrodynamic simulation IllustrisTNG50. We selected 16,000 galaxies below a redshift of 2, and we calculated the DM and RM from 1,000 starting points per galaxy. The restframe DM distribution is close to low normal with a long tail. The median of DM and its spread increases with redshift and can be fitted by a power law. Our values are also consistent with previous results. This change with redshift can be due to higher star formation rate, therefore higher electron densities at high redshifts. If we separate the galaxies by their stellar mass, we see that the DM increases with stellar mass too, except for very massive galaxies where the median DM is lower than for the others. These galaxies can be large ellipticals with a low star formation rate and low electron densities. The distribution of the restframe RM is symmetrical and with a strong peak at 0 with long tails. The width of the RM distribution increases with redshift after a redshift of 1, where it stops. If we separate the galaxies by their stellar mass, we can see again that the rotation measure increases with stellar mass, but for very high mass galaxies, the distribution width is lower than for others. The trends that we see are very similar to the trends in DM and can be partly attributed to the differences in electron densities too. The actual observed RM and DM contribution of the host galaxies is diluted by their redshift. So 95% of our sightlines have a DM lower than 280 parsec per cubic centimeter and an absolute RM below 450 radian per square meter. At higher redshifts, these values are even lower. These results can help future studies of the cosmic baryon density and intergalactic magnetic field by providing an estimate on the host contribution to the observed DM and RM of FRBs. Thank you for your attention.